is actually emerging analytics applications for health, safety, and wellness. Basically, what we have today is to have three very young teams, okay, to actually share with us what they have done using analytics and AI to impact society in a meaningful way. So we have three teams today with us. We have team Edu Tomahawk from ITE West. So later on, Emery will share on her projects that basically is a proof of concept project, right? They recognize hand gesture using AI machine learning. Then the second team is Team Tomase, who's a finalist in the Huawei ICT competition last year. They basically created a system that is able to detect falls among elderly using AI so that early detection can be triggered to provide the critical care required. And the last team that we share is the JP Awesome from NUS. So they are the emerged champion of the Splash Award 2020 last year. So the project is actually on an AI tool on physical disability and speech difficulties assistant based on eye tracking. So without further ado, let me just invite Emery to maybe start preparing her screen for the presentation. And also just a reminder that this session will be recorded so that people who are not able to join us today, they can actually play back the video and view this recording. All right. Emery, are you ready?
Yep, I'm ready.
Okay, so I'll hand over to you. Thank you.
Thank you. Oh, sorry. The screen sharing is disabled by the host.
Oh, okay. Camelia, can you share the screen for or allow Emery to share? I think she's. Can you try it again, Emery? I think it's.
I can now.
Can you try?
Yep.
You can, yeah. Okay. Good. Yeah.
Okay. I'm so
Sure.
sorry.
No worries.
Okay. So good afternoon, everyone. My name is Emily, and today I'm going to present my project, Smart AI Sign Language. So the project is very practical and was created to create convenience for the hearing impaired when they converse with anyone else around them, so as to avoid miscommunication and which help us all to stay connected. So I actually have a senior who has hearing impairment, and throughout his 2 years in ITE, he went through a lot of communication difficulties, which really inspired us to create this project. So we developed a proof of concept that is able to recognize hand gestures and translate it to text or speech using machine learning, allowing easier communication for the hearing impaired and the hearing. So to do this, my teammate and I learn the native sign language and Python so that we can transfer our knowledge into the project. So it is uncommon, if not pretty rare, to find applications like this, especially with the local sign language. So an example of a sign language app is the HandTalk app, which is only available for American and Brazilian sign language. So the benefits of this app is that it's convenient for the hearing to converse with the people hearing impaired, as it translates text and speech to sign using a 3D animated person that displays the sign on screen. However, it does not convert sign back to text or speech, which does not make it convenient for the hearing impaired if they want to respond back. However, for our project, it is convenient for the people with hearing impairment, as it translates gestures to text and speech, which I feel is much more important to focus on. However, it does need more training and there's limited gestures, but it is still a prototype, so there's always room to improve. So I'm now going to briefly run through the development stages of our project. So we imported the images from Teachable Machine and then split the images to the training and test sets. So there's estimated about 500 images for each word. So 400 for training and then 100 for testing. Afterwards, we created a model using the deep learning frameworks, TensorFlow and Keras, to create, predict, and train the model. Lastly, we fine-tune the parameters and to further evaluate and improve the project. So there's not much there's not much needed for our program. All we need is the laptop, a tablet, and a web camera to capture the signs. So this is what our project is like. So the user will have to gesture on the green box, as you can see on the left. The user have to gesture on the green box, and a word will appear on the text box. And as you can see on the right, it will then be able to structure a sentence. So this is our project development timeline for anyone who's curious. We did our user requirement on the November 2019. The system design in January 2020, our software development on March 2020, and our user testing on October 2020. So throughout the project, we encountered a lot of challenges. So one of them was image accuracy. Because we are only using our laptop web camera, so it's obviously not very good quality. So accuracy was quite an issue for us. So that's why we did about 500 images for each word, so that it can be as accurate as possible. And we realized that the background of the images are also a big factor, because it has to be it shouldn't be anything going on in the background. Otherwise, the program will only focus on the background rather than the gesture itself. So another challenge that we encountered was when we were researching on Singapore Sign Language. We realized that there's no full-length dictionary on the local sign language anywhere online for anyone to be able to access and learn. So for us, it's much harder than we thought to be able to search and look for the words that we wanted initially. And it also made us realize how the local sign language is pretty much unknown to a lot of Singaporeans, which I feel is pretty much a concern to me. So for the future enhancement, we want this project to be able to be accessible on mobile in the form of an application, and to include the Singapore Sign Language, full-length dictionary, Singapore Sign Language dictionary for all locals to be able to learn. So we're actually in the midst of partnering up with Casanova Children and Community Services and the Singapore Association for the Deaf, so that we can have some professional guidance and feedback and some input, so that we make sure that we're on the right track. And we will also want this application to be available for community centers and especially schools. So for example, in the US, it's pretty common to have American Sign Language as part of their school curriculum. So I really want that to be the norm for Singapore as well, for our schools here in Singapore to teach Singapore Sign Language. But of course, other than that, if our project is available as an application in schools, but the people with hearing impairments, for example, my senior, as I said, he went through a lot of communication difficulties. So he actually one day, because he has a interpreter following him around in school all the time. So there was one time where during a assignment, when there was an assignment due, the interpreter could not come to school like very last minute because she had medical leave. So it caused a lot of anxiety for him and also for the teachers as well. So we really want to avoid that kind of incidents and kind of stress that's really unneeded. So with our application available, it really kind of eliminates the need for an interpreter to follow him around, or at least in these kinds of emergencies, be able to have our application on hand to avoid anxiety and stress. So now I'm going to play a demo of our project. As you can see, he's gesturing inside the green box.
I am hungry.
And there's as you guys can hear, there's a speech function inside as well.
I feel happy.
So that's basically what the project is like. And that's all for me. Thank you guys for listening. Is there any questions?
Yeah, I think any questions for Emery? I also just want to add that how do we actually come up with this session is that we thought that it'd be very interesting for us as a community. I mean, like I always say that the BA chapter is a very close community that we always come together. And I think all the projects that we've selected today, especially like this one that Emery has just shared, is actually to address a critical social needs and in issues, which many a times we never really talk about it or even consider it. So it's also something that is very enlightening for me. I didn't know that sign language, right, of Singapore and Americans, they're different. So even though they do both person knows sign language, so technically speaking, they can't really understand each other totally, right? Am I right to say that, Emery?
Yes, it's kind of a shock to me as well. I realized how different American and Singapore sign language is as well for me. So it's quite shocking to me as well. Yeah.
Okay, so the communication can really be an issue, even if both person uses sign language.
Yeah.
Yeah. So hopefully with this, it can just eliminate any misunderstanding even between two person with knowledge of sign language. Yeah. And any question from the audience? I mean, if you do want to use the audio, you can also type in as well. I think we can actually see the chat. Anyone? Okay. So maybe later on, I'm sure we have some time, Emery. We'll come back to you if maybe people just need time to think about the questions, right? Yeah. Yeah. Thank you very much. And then Shimin, you're saying great project.
Oh, thank you so much.
Yeah. So yes. So for Yao Hui, are you ready? You're good.
Sorry, can you guys hear me? Yeah. All
Yeah.
right. Yep.
Yeah. I
Okay.
can hear you. Okay. Yeah.
Yeah.
Bring it away. Yeah. Hand over to you.
Nice. Okay. So good afternoon, everybody. So my name is Wong Yao Hui, and I'm part of a team that consists of me and Andrew, and we are representing Temasek Polytechnic to introduce to you this fall detection system for elderlies. So what the problem is that falls are the second leading cause of unintentional deaths, and falls are more fatal towards elderlies above the age of 65. Also, according to World Health Organization, so it is probably right lah. Then falls are also the main cause of morbidity and disability in the elderlies due to their slow response times for medical care. So what we're saying here is basically, oh, maybe you're at an elderly center and an elderly falls down just right outside the CCTV cameras range in an alley or whatnot. Then so the staff will not be alerted as quickly to help assist the elderly and give him or her the critical care that she needs. So with that problem in mind, we decided for our purpose is to create a system that detects the elderly falling and to alert the appropriate staff almost immediately, ensuring the elderly receive critical care, improving their rate of response, and potentially even saving their lives. So what our system has the following features for now. So a camera that triggers on motion sensor, a real-time prediction on falls, and the ability to record and save video with results and the timestamp, an LED light to determine fall status, and a website to view results and recorded video. So a brief description of our hardware and software used. So basically, when you see this device, uh, so the top left-hand corner is basically the logic board, which is a Raspberry Pi, and then connected to it, the top right-hand corner is a camera that's used to do the recordings and such. Then the bottom right corner is the motion sensor that will detect when a person goes into the vicinity of the system, and the LED lights at the bottom left will react accordingly whether a person has fallen or not. Uh, Fallen or not. So basically, so in order to do this, we had to train our model to detect whether a person has fallen or not. So here are the data set samples of what we used for people falling. And here are the data set samples of what we use that from for people that are not falling. So this is our prediction results when we first trained the model and not implemented to the Raspberry Pi yet. So basically, you can see here the left side is a picture of someone falling. So the model will respond it most likely belongs to a fall, and when a person is just walking about, the model will say that it most likely belongs to a not fall category. And we also have a website that records and shows the videos taken by the system. And when the model is predicted that someone has fallen down, the table actually turns red, as you can see over here. And so I'll show you a demo video for you guys to maybe understand it a little bit more.
For scenario 1, we will be showing what happens
Sorry, can you guys hear that? Oh,
Yes.
all right. So,
when the system does not detect a fall. As you can see, Andrew has triggered the system to start the prediction model and a recording. The Raspberry Pi screen shows the prediction as not fall, and the red LED turns on, signifying to the people who are not looking at the screen that the system has predicted that no one has fallen. And when the 30-second cycle ends, the system will then store the video into Firebase. The website will then immediately update the dashboard, as you can see here, where the user can then view the video to double check if the system's predicted result was correct. Showing what happens when the system detects a fall. As you can see, Andrew triggers the system and falls. On the Raspberry Pi screen, it shows that it is detecting a fall. However, the system needs to confirm that Andrew has really fallen down, so it will take a few seconds before the green LED turns on, turning off the red LED light, signifying to others who cannot see the screen that someone has fallen down. The system does the same 30-second recording as it did in scenario 1, but now, instead of the prediction results showing not fall, it shows fall. And on the website, it will be highlighted in red to alert users of this application. It also shows the device name, stating it as Raspberry Pi 1. In the future, these will be names of locations, for example, Corridor A, Corridor B, or Lift Lobby, and so on.
yeah, okay, so after watching this video, you guys have more of an understanding on how this system works. But then it doesn't stop here, because in the future, someone can take it and improve it even more to even spread across the spread. So it will not just include elderly, but maybe include toddlers as well. So maybe you can put a camera at home, and then so basically what is the core thing here is the prediction model. So if you can train it right, train it accurate, you can predict literally anyone falling. So it opens up to audiences and not just elderlies and people in need. Which makes this very malleable, and you can even put it in CCTVs also. So you can make them so using putting these models into CCTVs kind of makes it a IoT product already. And then we all know all the hype is about IoT these days, like connecting to the internet and such. So if somehow we were to implement this model into current CCTVs, we can make them an IoT product and so on. Yeah, I think yeah. Oh, sorry. Yeah, that's the end of my presentation. Do you guys got any questions?
Any questions for Yao Hui? I think there's one.
Do you face false positives? Yeah. So basically, the accuracy now. So I did some research on the web. The accuracy is determined by which is kind of the main factor is the background. So we haven't found a way to solve the situation yet. because due to our inexperience, so basically it's our first time working with prediction models and such. And then given the time frame, so basically we were given like uh 10 weeks or so, also to work to look up and to make it as accurate as possible lah. So we just try our best lah. And it's not like 99% accurate. That's why I say in the future someone can take this, or maybe our team can further improve on this to make it very accurate and available and make it usable for public use.
Hey, Yahweh, I got a question.
Yeah.
So basically, right, I mean, when you're building this project itself, what is actually the limitations that you actually encounter? Whether is it the hardware limitation, software, or whether is it the the testing, for example,
Oh yeah.
any limitations?
So as I said before, I said when I answered the Mr. Lau's question. So one limitation is inexperience. Our first time doing it. So basically, what we did was just we referenced from multiple websites, and then we how to do this, how to do that, etc. etc. Edit it, make it and then make it usable for our user. But we know that there is some like out there. There's someone that can like make this much efficient, because right now the videos are about like 5 to 7 frames per second. And then when you see those videos where they are like commercially produced, you can see a smooth like 30 to 40 frames, and then a box tracking the faces of the people. Yeah, that's what we like failed to that's what we couldn't do lah. uh couldn't do couldn't do. And then hardware side, actually this was just a prototype, and then because we chose the Raspberry Pi because there were the most number of references out there for us to for us yeah, we do not know like what is the like the actually most the best in the best stuff to use, so we just rely on the internet and just try our best to understand everything in a short amount of time. Yeah.
Yeah, fair enough. Because the better hardware you use, of course, the cost will go up. So I think that's also one consideration. Any other further questions or any other questions for Yao Hui on this? Yeah, I think this topic was chosen because it is a real problem for old people. We know that what we fear most for old people is falling, right? Even if the fall is not fatal or very serious, I know that after a fall, old people sometimes do not regain what they were before. It kind of damages a lot of things in their body, whether it's a hip or is even worse, a head injury or something like that. So I think it's a problem that I think they identify, and using basically AI as well as the Huawei software, they can actually do this. And I think like what Yahweh says, you can really tweak it and basically improve the model, yeah, as it goes along. Yeah. Okay. Okay, I just want to also check, is Ziao back from his meeting, Camilla?
I'm attending now.
Okay. Hi, Ziao. Okay. Yeah. So I'll just hand over to Ziao. Ziao is actually from NUS, and they are actually the winner of Splash Award 2020, as I mentioned earlier. So I'll hand over to you, Ziao, for you to bring us through this project. Yeah.
So hi guys. So I'm really honored to be in this platform to share our project for winning the 2020 Splash Awards. So let me share my slides first. Hi. Can you give me hi? Can you give me the permission to share my screen? Yeah. So no, I can't share. No, never mind. So this is Zhi Yao. So I'm from Computer Science School of Computing, National University of Singapore. So together with my partner Jia Jun also attending here. So our project is mainly focused on visual therapists. So I can share, right?
Yes, you can go ahead, share now.
I can share it now. Yeah. Sorry, wait for a while. You guys all can see my slides, right?
Yes, good.
Yes, can see.
Yeah, so our projects mainly focus on develop some projects facing physical disability and speech difficulty assistant. So based on some like mm, object detection, smart answering, and TDU predictive input methods. So what we want to really achieve is to help this group of people who has a physical disability and speech difficulties. So let me talk more about our research and background. So before we implement these projects, we have doing some like survey. We found that 3 per 1,000 people have cerebral palsy in Singapore, and also 400 people have amyotrophic lateral sclerosis. 3.2 per 1,000 people have stroke also. So this above data is only part of people with physical disability and speech difficulties. What we call it is PTSD. So there are still many people who cause PTSD due to other diseases or accidents in all over the world. So what we find the problems among this group of people is they can't tap or speak, or it's difficult to make friends online, and also many handed in current market cases, so many handicapped is available, is very expensive, so high cost. So it's still troublesome to use lips or voice to control it. And with in their family members, PTSD family need to trouble some to take care of them. So what we want to achieve is to basing our project to assist them, to allow the people with PTSD to effectively communicate with anyone and anywhere with our assistive application. So like using our own techniques such as the smart answering with T2 predict input method, eyes tracking for system control, object detection assistance, and muscle movement detection for system control. So these are all new methods for helping the physical disability and speech difficulties of this group of people. So in our system diagram, we simply introduced about it is we many developed in the mobile application by connected with the Bluetooth master sensors and store our own design algorithms in the backend AWS server to do the cloud computing, such as the speech to text and text to speech recognition and automatically smart answering words, and also object detection, eyes tracking, word recommendations. So this is a simple introduction about our backend algorithms. So let me talk more about our project can simplify bring the benefits to this group of target users, such as it's easy to initiate conversation with others, high target population coverage, high scalability, excellent user experiences, and with low cost and affordable prices, and simplify the operation to greatest extent. It also can enhance the understanding between the normal people and the families with the PTSD. So in the future, we may also make a cross-platform can cover in Android and also in the iOS platforms. So we have gain a lot of supporters such as the Antaker Singapore give us some like support, help us to connect with the disabled people association and give us some like good feedbacks and support us to do more. So this is also simple testing users we have gain the support from them with the agreement. I can show the picture with all of you. So since due to the COVID-19, we only conducted a few beta testing. So we will work with more disabled people in the future also. So in conclusion, let me talk more. So we simply maybe set on business model is free app downloaders, software as a service, charge as a subscription model, and sell some like master sensor keys, charged by per set. So our innovation points at using lots of AI techniques such as the auto predictive input method, eyes tracking for system control, and object detection assistance, and master sensor detection for system control also. So that's all about my sharing about my project for physical disability and the speech difficulties assistant. So I maybe can share one video demonstration for all of you to share, to take a look about our simple projects. Yeah. let me share first. I'll wait for a while. Sorry for waiting for a while. Yes. Let me share it. So. Sorry. Yes, here. So you all can see here, right? My demo videos.
Firstly, after the people with physical disability and speech difficulties, which is simplified as PDST, log into the application will do the eyes calibration for the eye checking so that the people with PDST can control the whole application with their eyes. And this is a gaze point of the eyes, and this is a gaze time of the key event. For the first scenario, the people with PDSD need to communicate with each other. Firstly, the application will filter out the nearby people based on the real-time locating. After selecting one of the contacts, he or she will receive the greeting message and can start chatting immediately. Then the user can either select one of the auto-generated response or enter his or her own response via the T2 predictive input method with the eye checking. Then the response will be sent and played via the text-to-speech.
I am bad.
For the second scenario, the able-bodied people can use the microphone to communicate with the people with PDSD via speech-to-text. Hi, how are you? Similarly, the user can either select one of the auto-generated response or enter his or her own response via the T2 predictive input method with the eye checking.
I am not well.
For the third scenario, in order to make it more convenient for the people with PDSD to express themselves, the application can automatically detect the objects in the surrounding environments to generate the possible response, and the user can select one of it to play via the text-to-speech.
This keyboard is very beautiful.
Lastly, we also decided an alternative option for the people with PTSD to use the muscle sensors to stimulate the selections and the click events instead of the gaze.
So this is the master sensor keys for our project, yeah.
Is this keyboard comfortable for typing?
That's all for our demo.
So thank you so much. That's all about the sharing about our projects. Thank you so much.
Thanks, Xiao. Let's give a moment to see any question. I think, are there any questions? Hi, there's one here. I think the question is, how do you manage to track the letter selected by user since the gap between the letter is so near to each other?
What do you mean the gap between letters so near? Can you speak it out?
If I'm not wrong, right, I think it's Mr. Lau. I think it's probably asking about how do you make sure that the accuracy is there, because the between the letters is very close.
You mean that each words link relationship, right? So we basically is basing some like a Thai architect structures. So it's like basically to link the memory of the each words, like then the training each words as the single part. And the if you know the data structure about Thai, each words link to another part of the each another characters. So we will just give some weights of each memory and then train these kind of things, then output a model for prediction each words first. Then if like every times the users to using this, then to output to such as a classifier to classify which part much more linked to the words they used previously. Yeah. Yeah, this is I can share.
I wonder if Mr. Lau, is it okay? Nope. I mean, how do you know that that's like B? Yeah, it's the accuracy, I think.
So I don't think this we will just make as the B, A, C as single characters. So I will just making as the total words as a whole identities.
Okay. Are there any other questions? Any further questions from anyone?
Yeah, thank you so much.
Thank you.
Vivian raised her hand, allow her to talk. Where is she? Vivian, are you there?
Is it Vivian?
Oh, no.
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 Okay. I guess, Camilla, do you want to use this opportunity if there's any announcement or anything you want to inform the group? I think it will be probably the last time we kind of see each other before the AGM, right?
Yes. Our BA chapter AGM is on the 9th of March. So anybody who is keen, feel free to join us virtually. It will be a virtual AGM. So you can see on the slide, there's a QR code and also a link where you can share with us your feedback on today's session. I can also share my slides on the upcoming events, but I'm just wondering, any further questions from the audience?
Yes, any further questions? Yeah, for our young innovators here. Yeah, I think it's really well done to all of you, and do please continue to create the solutions to solve critical societal issues. A lot of times we see applications and innovations, right, that they make money, but a lot of, yeah, I think that the key here is that there's still a lot of very important critical societal issues that we need you guys to create and keep creating, and hopefully we actually can solve a lot of these problems together. Yeah. Thank you again.
Okay. Yes. Thanks to all the presenters, your student presenters. You're very well done. We're glad that you managed to come join us even at short notice. So do continue to participate in our SES events. We welcome all of you to continue joining us in our ideas, which is basically focusing on analytics, on AI, and probably this is our focus lah. So if there are no further questions, I'll actually be sharing some slides on the upcoming events, and then also a QR code here for all of you to share your feedback with us. Okay, we hope you can actually scan the code and then let us know what topics you like to hear from us so that we can organize the events for you either virtually or perhaps actually our next idea should be at NLB. They have given us approval to actually organize our event there, because previously we were doing it at NLB. So for today's session we can't, but they told me that in April, I think we'll be able to see each other in person at NLB. How about that?
It's been it's been a long time, right, Camilla?
Yes, that's right.
We
So
used to enjoy seeing each other at the National Library.
yes.
Yeah.
So maybe you can keep yourself updated. Check out our SES website, www.org.sg, and then find out what are the upcoming events that's been lined up for all of us. Okay, sure. Thank you so much. Have a good day, and we hope to see all of you in person soon. Thank you.
And yeah, take care, everyone. Yeah.
Take care.
Take care.
Thank you so much.
Bye-bye.
Bye.